This problem is problem number 3 on the homework assignment on section 3.1 of your textbook. Problem number 3 is the same as problem number 4. So I would suggest that as we do problem number 3 together right now, you write it down and then you'll have the answer for number 3 when you're doing the homework, and you'll be ready to solve the problem when you get to number 4. This problem is about vocabulary words. So the first vocabulary word that we're going to start with is we are going to start out by finding the vertex. The vertex is the highest or lowest point on the parabola. Our vertex is at 1, -1. And so when we would come down here and we would fill in 1 and -1. The next vocabulary word is the axis of symmetry. The axis of symmetry is always given as an equation of a line, and it's the line that divides the parabola into a mirror image of itself. On this problem, that line will look like this. The axis of symmetry will always go through the vertex. And since our axis of symmetry is vertical, which it will always be, its equation is x equals 1. So our axis of symmetry is x equals 1. Notice that we are using the number 1 twice on this problem. The next vocabulary word is the domain. The domain is a list of all the x coordinates of every point on the parabola. So right now, you can see the arrows pointing at some of the x coordinates of the points on the parabola, but there's infinitely many more points on the parabola and infinitely many more x coordinates that go with those points. Since the parabola starts at +1 and goes to the right forever, and starts at +1 and goes to the left forever, our domain will be all real numbers. The next vocabulary word is the range. The range is a list of the y coordinates of every point that is on the parabola. So right now it looks like our range is -5, -2, -1, -2, and -5. So what I noticed about the range is if I look at the patterns of the y coordinates, it seems like at -1, it turns around and starts going back down. So on this picture, we will never have a point on our parabola that has a y coordinate that is greater than -1, because our parabola is not on the part of the graph that's greater than -1. So our range will be written like this. Y is less than or equal to -1, because every y coordinate for every point on our graph will be less than -1. The next vocabulary word, they want to know when x is less than 1, y increases as x does something. So when x is less than 1, well, which part of the graph has an x that's less than 1? It's this part of the graph right here that I'm highlighting in purple. That's where x is less than 1. So as I move from one point to the next, my y's, -5, -2, -1, my y's are increasing. What's happening to my x's? -3, -2, +1. Our x's are also increasing. So this spot right here should be filled in with the word increases. And finally, when x is greater than 1, well, when x is greater than 1, that's the part of the graph that I'm highlighting in orange. X is greater than 1 right here. And they want to know when x is greater than 1, y increases as x does something. Y increases. So the y coordinates, this is -5, changing to -2, changing to -1. So the y's are increasing. What's happening to the x's? 3, 2, 1. So as the y's are increasing, the x's are decreasing. So we fill in the blank. When x is greater than 1, y increases as x decreases. This is problem number 7 from the homework. This is to help you do problem number 7, but also it's a good example of number 5, 6, 7, and 8. They want us to identify the graph h of x equals 1/4 x squared. When we look at that equation, we can see that our a value is 1/4. Whenever your a value is a proper fraction, your graph will be a vertical shrink compared to the parent function. So we know that our graph, the graph of h, is a vertical shrink by a factor of 1/4 of the graph of f, and the graph of f is the parent function. So the big graph in the middle of the screen, that is the parent function. And we need to take the parent function, perform a vertical shrink of 1/4, and then choose the graph that looks like the parent function after we've performed that vertical shrink of 1/4. Now, all of these graphs can be a little confusing because of the scale. So if you look at the x-axis, here's 1, 2, 3, 4, 5, 6, and here's -1, -2, -3, -4, -5, -6. So on the x-axis, every square is 2. On the y-axis, every square counts as 1. So when you're looking at the locations of the points on the graph, you have to take that into consideration. The scale on the axis x is not the same as the scale on the y. So we're going to be able to find the right graph by looking at just one point. I'm going to look at the point -2, 4. So for my parent function, to get to that point on the graph, I need to go 2 to the right and up 4. Well, if our graph is undergoing a vertical shrink of 1/4, that means when we go over 2, we're not going to go up 4, we're only going to go up 1/4 of that amount. And 1/4 of that amount is 1. 1/4 of 4 is 1. So our graph will pass through this point right here. Instead of going up 4 like the parent function, it'll only go up 1/4 as much, so it's only going to go up 1. So we're looking for the graph that goes through the point 2, 1. So when we go to our first graph, 2, 1 would be right here, and our graph doesn't go through that point. In the second graph, 2, 1 is right here, and our graph doesn't go through that point. Underneath it, 2, 1 is here, and our graph doesn't go through that point. But on this side, 2, 1 is here, and our parabola does pass through that point. So the graph of h of x equals 1/4 x squared is this graph right here. On problem number 11, they want us to identify the graph of k of x equals -0.2 x squared. When we look at that equation, we know that our a value is -0.2. If your a value is a proper fraction and 0.2 is a proper fraction written in decimal form, then we are going to have a vertical shrink. So we know the graph of k is a vertical shrink by a factor of 0.2, and then it also has a negative sign in front of it. So that will cause a reflection over the x-axis. So if we take the parent function and perform a vertical shrink by a factor of 0.2, and we reflect the parent function over the x-axis, we will have the graph that we're looking for. On this problem, to identify the right graph, I'm just going to make a table, but I'm only going to use 2 values because I think if I know 2 values, it'll be enough to identify the right graph. So if I replace the x in the equation with 2 to the second power is 4, and 4 times negative 0.2 is negative 0.8. And if I put 4 in for x, 4 to the second power is 16, and 16 times negative 0.2 is negative 3.2. So I want to find the graph where the line, the parabola, goes through 2 comma negative 0.8 and 4 comma negative 3.2. So to start out with, I'm going to look at the point where x is 4. Here, there, x is 4 and y would be 10. That is definitely not the right answer. Here, x is 4 and y would be like negative 14. That's definitely not the answer. Here, where x is 4, y would be, I don't know, off the charts, like at negative 20. So that's definitely not the right answer. But right here, if we look where x is 4, y is a little bit above negative 4, like possibly negative 3.2. So this is the correct graph. So as you can see, on the last problem, I used the parent function and I performed the vertical shrink to find out what the graph would look like. On this problem, I just made a table to find out what the graph would look like.